Hi, welcome to our second video for 2.7 inverse of a function. Just to review real quickly, an inverse function will undo another function. Okay? Inverse functions are always denoted by the symbol f (-1). So this is not an exponent, it's just a symbol used to describe the inverse of a function. We can also apply this to y, so y minus 1, that also means inverse. Okay, and real quickly, since we're talking about that, when we have f to the -1 or f inverse of x, this is not equal to 1 over f of x. Okay, we can't treat this as an exponent. Okay, we have to be very careful about that. So, yeah, whenever you see this, it doesn't mean to just flip the f of x or take the reciprocal. We cannot do that. That is not a rule. So that will lead to an incorrect answer if you do things that way. So an inverse function. So all inverse functions have this property, okay? And that property is that if you insert a into the function, so a represents some input, well, after it's processed, you get an output b. Well, if you take that output and you put it into the inverse function, it's going to give you an output a, which was the original input of the first function. So what I mean by that is for the first function, if you put in a, your output will be b. Well, take the output b and use it as the input for the inverse function. Well, it's going to output a. So you can see the undoing process. That's what inverse functions will do. Okay, so let's go into our first example. In this example, we just want to algebraically find the inverse of a couple functions and then graph them. And then afterwards, look at the inverse functions and determine whether or not they are actually functions. Okay, so let's begin with the first one. So it's probably going to end up getting a little bit of tight for space on the page. So just be a little bit careful of that as you're doing the solution. I'm going to write a little bit bigger and then I'm going to compress it afterwards. So for a, we want to take the function f of x equal to 2x minus 3. Okay. Our first step should be to write this as y, f of x. That way we can just go ahead and switch x and y. So we kind of got to switch those two around. We'll say switch x and y. So then we would have x equals 2y minus 3. When we do that switch, and then when we isolate for y, we have to we're going to end up reversing all the processes on this right-hand side. And when we do that, we're actually undoing the function. So it's setting us up for the inverse. So the next thing we want to do is just add 3 to both sides. That'll cancel this out. Add 3 to that side. So then we have x plus 3 equals 2y. And as you might have guessed, divide both sides by 2. That will get rid of this. So now y is isolated. Okay. And don't forget this last step. We want to write this as the inverse. It's very important that you write it as the inverse because it is the inverse function. Okay. So that is the inverse of the first one. Okay. And we're then asked to graph it. So graph the function and its inverse. So we could easily graph this one here. Just a linear equation. So we'll move up over here. Actually, I'll start this over here. So there's my y-axis and then the x-axis. I'm just trying to get these through the middle of the graph. Okay, so we'll do the original one in black. So I can see that's in slope y-intercept form. The y-intercept is -3. Okay, I know that from the -3 here. That's the y-intercept, the v value. And the slope is 2. I can see that from here. The slope is 2. So from the y-intercept, I got to go over 1 up 2. That would have a positive slope of 2. So I kind of have a bunch of points here. I'm just going to plot a few more, and then I'm going to draw a nice clean line through all of this. So that is my equation, f of x. Okay, now graphing the inverse is actually kind of fun. We don't really need to do anything with this equation, although we could, try to rearrange it into slope-intercept form and then graph it, or set up a table of values. But what I'm going to do is I'm just going to take my knowledge about inverse functions, and I know that inverse functions always, there we go. They always reflect along the line y equals x. That's one of the properties of inverse functions. So if you remember from the PowerPoint video, we had showed this. This is always the line of reflection. Okay, y equals x. So that's kind of like if I take my sheet of paper and fold it along that red dotted line, the points would map over to the other side of the line. Okay. All right, let's go back to solid lines there. Okay, I'm just going to mark off a couple more on the black line so we can see. So when we find the inverse, all we should do is, I'll do this one in blue, we should just switch the ordered pairs around, the x and y values. So for instance, let's focus on the y-intercept here. This has the point 0, -3. Well, when I do the inverse, I'll get -3, 0. So -3, 0 would be right here. And then I can grab a couple more points. All I really need is 2 or 3. I can grab, let's say, this one right here. That one looks like it's 5, and then the height is going to be 2, 4, 6, 7. So this is the point 5, 7. Well, the inverse is going to be 7, 5. The x and y will switch. So 7, 5 is going to be 7, and then up 5. That would be right here. Okay. Also, whenever you're doing the inverse, any points that are along the line of reflection are going to remain unchanged or invariant. So that's actually a point for us too. Because when you fold along the dotted line, any points on the dotted line won't move. Okay, I'm just going to draw a line through here. So let's start about right here. I also know that, like, when I do the inverse of a function with a slope of 2x, the inverse actually has a slope of a half x. So I can also see I have a slope of a half. So from one point, if I move over 2 and then go up 1, I get the slope. Okay, so that is f inverse x. Okay, another characteristic you'll see is that the distance from the points, they are equidistant with the reflection line. Okay, so meaning the distance from here to here is the same as from here to here. Okay, that line that you draw always needs to be perpendicular with the reflection line. Okay, so that's the first function. We have it graphed. The inverse is graphed. And now the last part, it says determine whether the inverse of the function is a function. So is this blue line a function? Well, yeah, it definitely is. It does pass the vertical line test. I'm just going to draw a vertical line. Okay, this could be my vertical line test. So if I take this and I slide it along the graph, you can see it always intersects the blue curve just once. That's pretty obvious. We'll get rid of that. And we can also tell by looking at the equation, right? And this equation, if you put anything in for x, you're not going to calculate two different values for y. So each value of x that goes in is only one possible output. So this function is definitely a function. So the inverse function is definitely a function. So you have to be careful. When you're doing a question and it says find the inverse, so you don't know if that just because you're starting with a function doesn't mean your inverse is going to be a function. It doesn't necessarily work like that. So we'll have to be careful and check those. So let's just summarize our response. We can say f inverse x, okay, is a function. Okay, notice how I pronounce this. I know earlier in the video I said f negative 1, but it is actually kind of wrong to say it like that. This we always want to pronounce as f inverse x. I'm just going to add that in just to make sure we're pronouncing things properly. So we can say, we'll say f inverse x. So that's how you want to pronunciate this. F inverse x is a function, and now we can say y. So since there is only one y value for each x value. Okay. So in other words, it passes the vertical line test. Okay. So that was for that last part right here. Okay. All right, so like I said, space is going to be a little bit tight, so I'm just going to compress this, and then we'll start the next one. The next one won't be as simple as this one here, and I'll explain why in a second. So when we look at this one for part B, I'm first going to switch f of x with y. Okay, and now you're probably realizing where we're going to run into a problem. So remember, when you find the inverse, the first step after you have this expressed as y is to switch x and y. So, but you notice here there's two x's. Okay, so what we don't want to do is we don't want to write both of these as y. Okay, we want to actually change the form of this. If we can change the form of this so that there's only one x, we want there to be only one x term. So is there an algebraic process that we can do to this? This is in standard form. Can we change the form so that there's only one x term? Okay. So if you want to pause the video and think about it a little bit, you can. Otherwise, what we want to do is we want to put in standard form. Sorry, put in vertex form. Put in vertex form. Okay, why would we want to do that? Well, vertex form, if you notice, there's only one x term. So if I can take this and get it in vertex form, then I'll just have one x term, and then I can go ahead and switch x and y. So we'll say put in vertex form first. Okay, how do we do that? Well, last unit, you learned this, and all you have to do is complete the square. So let's go ahead and do that. If you want to pause the video and try to do this on your own, I encourage you to do so. Okay, so first step is to factor out 2 from the first two terms only. So we'd have x squared plus 16. Okay. Oh, I forgot my x in there. 16x. Close up the bracket plus 29. So we only factor the 2 out from the first two terms only. And I just noticed I forgot to divide that by 2. So that should be an 8. Okay, apologies for that. So we're dividing the first two terms by 2 because we factored out 2. So 2x squared divided by 2 is x squared. 16 divided by 2, 16x divided by 2 is 8x. Okay, you can always multiply this in, and you should get exactly what you have up here. All right, so that was the first step. What do we do next? Well, we have to add that special term to make this a perfect square trinomial. So what we do is we add a b over 2 squared. Okay, so in this case, b over 2 squared, b is 8. This is my value for b. So 8 over 2 squared, that's 4 squared, it's going to be 16. So we're going to have plus a 16 minus a 16, close up the bracket, plus 29. Okay. So I've now created that perfect square trinomial, which is right here. Okay. All right. I like to, before I factor, I'd like to take out this negative 16. I'd like to take it out of the bracket. I can't just take it out because everything in the bracket is supposed to be multiplied by 2. So I'm going to do that first. I'm going to multiply this by the negative 16 by 2. So we have y equals 2, x squared plus 8x plus 16, close up the bracket, minus 32. Okay, negative 16 times 2 is negative 32. Then we have plus 29. Okay, now we can see that perfect square trinomial. I'm just going to factor that next. So that factors to the square root of the first term is x. Square root of the last term is 4. And then the sign of the middle term is plus, so we have a plus here. That's exactly how we factor that perfect square trinomial. Minus 32 plus 29, that's negative 3. Okay, and we can call that done. That is now in vertex form. So now that we've done that, we can go ahead and finish what we were trying to do with this question. So this question, remember, we're trying to find the inverse. So now that we've gone from this with 2x terms, we now just have 1x term. Okay, and switching x and y will be really easy. So that's our next step. Switch x and y. So we're going to have x equals 2 times y plus 4 squared minus 3. And now we got to isolate for y. Okay, we got to isolate for y. Okay, when we isolate for y on this side of the equation, we're reversing all the processes that are happening in the y. And as we reverse all those processes, we're creating the inverse function, because that's what inverse functions do. So what do we want to do first? I want to get y by itself. So be real careful here. So it's kind of like we kind of have to follow basically like BEDMAS. So on this right side, if I want to get y by itself, the only thing I can do is I can either like try to multiply this side by something or divide, or I can try to add or subtract. So remember, whatever you're doing to this right side, you're doing to the whole expression. Okay. So if you say, okay, Mr. A, I want to get y by itself, so the first thing I'm going to do is divide everything by 2. Well, that means you're dividing the whole thing by 2, not just this term, but also this term at the end. Okay. So if you do that, you're creating a fraction over here. I don't recommend that. What I would like to do is get rid of anything that's hanging on at the end, any extra terms. So reverse those first. So my first step would be to add 3 to both sides. Okay, add 3 to this. And when I say add 3, I'm adding it to the whole equation. What happens is it just cancels out with here. So you add 3 to that side, you got to add 3 to this side too. So we're going to have x plus 3 equals 2 times y plus 4 squared. Okay, these canceled out, right? Okay, what should I do next? You say, Mr. A, well, why don't we square root both sides, get rid of the square? Well, if I square root this whole side, now I'm square rooting the 2. Okay, and I don't really want to do that. I probably want to get rid of the 2 first. So we can go ahead and do that, divide both sides by 2. So that cancels with this. Okay, I can cancel those out because these are like factors here, right? I can cancel out the common factors. Okay, and I'm already running out of space, but I know this will be okay. We're going to have, we'll just get this right underneath here. X plus 3 over 2 equals y plus 4 squared. Okay, now y is almost by itself. I would just like to get rid of the squared part now. Notice I can easily square root both sides. That gets rid of this. Square rooting a square, that reverses that. And that means I have to square root the whole left side. Okay, make sure your root comes down nice and low, and that way you get the denominator in it as well. Okay, let's try to finish this up over here. So whenever you square root something, you get a positive and negative solution. Okay, so there's actually going to be, I'll keep this in pink, I'm going to write the plus or minus here. Okay, so we can't forget that. All right, so we have y plus 4. Well, let's write this like this. Plus or minus the square root of x plus 3 over 2 equals y plus 4. Now we just got one step left. Just subtract the 4 from both sides. So here we'll have a minus 4. I can write it like this because it's basically minus 4 plus or minus that, right? So I like to have this in front instead of having it on this side. So let's just kind of keep that here. So that's my final answer. I'm going to write it like this. Y equals negative 4 plus or minus the square root of x plus 3 over 2. Okay, and remember, this is the inverse, so don't forget that minus 1. Okay, if you do forget to put that in, you will be losing probably like a half a mark on a question. So that's not a half a mark that you want to lose. Okay, all right, so now that that's done, we can go ahead and work on our graph. So graphing this one, we can also set up our axis kind of right through the middle, or almost the middle. So there's y, and then here's x. Okay, I'm always going to start with the original function because I don't really want to try to graph this right now. I could, and all I know is that I see quite a few transformations here. So this would be like my vertical shift. This would be a horizontal stretch of 2 because k would be 2. And then the plus 3, that's going to mean to the left 3 units. So that's a lot of steps to do. I'd rather just work with my initial function right here. Instead of using this form in standard form, I like this vertex form a little bit better. Because remember, I get the vertex from here, and it'll be pretty easy to kind of get the graph for that. So let's go ahead and plot that. I will do this one in black. So I'll just highlight this in black here. Okay, the vertex is negative 4, negative 3. So negative 4, negative 3 is right here. Okay. I also see that it's like stretched by a factor of 2. So that means instead of doing my next points like 1 over and 1 up, like a normal quadratic, if it's stretched by 2, I can go over 1 up 2. So I know my next points are here and, too far, right here. Okay. So once I do that, I probably should have a couple more points. So following that step pattern, the next one from here, I'm supposed to go over 1 up 3. Well, if it's a vertical stretch of 2, then I'm going to have to go up another 3, so 6. So 4, 5, 6. My next point would be up here. Okay. So I'm going to go ahead, I'm going to mark those down. That's right here and right here. Okay, so now doing the inverse, well, that's actually quite easy. I feel like we've already kind of done the hard part, getting the inverse function. So I'm just going to draw that reflection line passing through the origin. going to clean that point up a bit there. Okay. All right, so let's go ahead and let's do the inverse for the points. So we'll do the inverse in blue. So this point here, this is the point over 4 down 3. So this is the point -4, -3. When I do the inverse, I'll get -3, -4. So that's going to be right here, -3, -4. Okay. If you want, what you can do is you can kind of write out those points. So let's say for the base function, I didn't realize that was still on. Okay. So for the base function f of x, you can just kind of look at your graph and pull the points from it. So -4, -3. Then the next one was -5, -1. And then we had -6. And that was at a height of 5, I believe. Yeah, -6, 5. Or +5, sorry. Okay, so those are a few points there. I'm just going to grab the other ones here. So that's -3, -1. And then we have -2, 5. So those are for the base function. For the inverse, those are just going to switch. The x and y just switch. So we'll have -3, -4, -1, -5, 5, -6, -1, -3, 5, -2. Okay, so yeah, we already have -3, -4. So -1, -5, that will be right here. And then we have 5, -6. So 3, 4, 5, -6, that'll be right here. And then we had -1, -3, that's here. And then we have 5, -2, that's right here. So you can see if you fold this image on this sheet of paper along this line, the parabola, because the folding is on an angle, it actually looks like it kind of rotates. But anyway, it maps over on this side. Okay. So that is the inverse function. Sorry, let me just fix that there. That's the inverse, and then here is our original. Okay, you always want to make sure the graphs are labeled. Okay, so like I did say, it will take quite a bit of space. Hopefully you can write a little bit smaller on your page. I tend to write a little bit bigger just to make it a little bit easier to see. Okay, so that is it for this example. So, oh wait, we have to actually answer the last question here. So for our inverse function, we need to know that last part, determine whether the inverse is a function. Okay, so is this a function? So we can tell it isn't. So first off, we can see from the vertical line test, okay, if we grab that line and slide it across, it's always intersecting at 2 points. So it fails the vertical line test. So it's not a function. So we can say f inverse x, not a function. Okay, we can also tell by looking at the table of values here. We can see that when x is -1, the output is -5 or -3. We can also see when x is 5, the output is -6 or -2. Okay, that's it for this video, for this example. I will see you in the next one.